Okay, I think we should get started now. We have close to around 60 people coming here, and I suppose more people will join in. Uh, a very quick introduction. My name is Vishal Bhatt. I'm one of the founders of this organization called ThinkTac. And before we get into the actual demonstration of some of the activities, let me give a background about the organization and what this training is about, what this program is about. So as you can see in these slides, there are a few smiling children. So this is what ThinkTac is about. ThinkTac name comes from two words. Think is something that we all can connect to. TAC, which is spelled as TAC. Quite often people make it think tank, but it's TAC, standing for tactile. Tactile means doing things with hands, using your body senses to understand the world around. So ThinkTac believes that when we do that, the thinking is richer, children go through experience, and simple materials is the key that we use, and that leads to happy and engaged children. We started doing this work sometime in 2014, and we started as a non-profit organization called Innovation and Science Promotion Foundation. Uh, at that time, we thought only the underprivileged children need this, but as we started working with uh, more schools, more children, and teachers, we realized that the so-called privileged children are also not as privileged as they may seem. So we started this organization, which is for profit, called ThinkTac, but our mindset continues to be the social mindset, and we try to continue to put impact before business. In 2018, we partnered with the Raman Research Institute Trust, which is the foundation, the trust which was founded by Sir C.V. Raman himself. This was done in 2018, and in association with the RRI Trust, we have started this national level competition called Raman Awards. Uh, if you have not heard about it, please go to the website. It's a free contest for any child all over India to take part in. In fact, we are privileged to be working from Sir C.V. Raman's home in Bangalore. Uh, and now it has the association has been long. We are also taking multiple other initiatives. A quick background of the people behind this work. Myself, I take care of the products and the services. My colleague Ravi Rangan, who is the CEO, uh, and the principal scientist, who is kind of the brain behind a lot of this work, Dr. Prashita Malik, and Raghu. So four of us started this work, and the all of us had other options, but it's the cause which motivates us, and that's why we are here. All these 8 years, we have worked with a large number of children as well as teachers, and also a large variety of children and teachers. The work has been spread across 13 states. We have worked with private and government schools, and also schools located in villages as well as cities, tier 1, tier 2 cities, metro cities. And it's based on this rich experience that we are now confident that we have something which should work, a solution to implement experiential learning inside the classroom, which should work for children and teachers of all socio-economic backgrounds of our country. Uh, we have been partnering with various organizations. During the pandemic, we donated some of our content to the CBSE board, and in fact, CBSE issued a circular last year saying the ThinkTac experiments, which were mapped to the Ncert list of experiments for 9th and 10th, they can be used as an alternate to the lab experiments, since children were not able to access the laboratories as regularly. We have a lot of content available on Diksha. Pratham Books and Oxford University Press, they have also published some of our activities on their platforms and books. ActionAid has been one of our old partners. Uh, we have now started, as I said, in this 8 years, the kind of a survey that we did that has given us the confidence that we now have something which can be taken at a large scale. So we have now started approaching various state governments. As of now, these two states, which is our own Karnataka and Uttarakhand, these two states have signed an MOU with us, and we are extending our 7-activity curriculum mapped annual program to these two states. Let's talk about this partnership with DSERT and what exactly it includes. So as I said, we have this content from grade 1 to 10 for science as well as maths, and it has been mapped to the respective curriculum. So curriculum aligned program of 7 activities from grade 1 to 10 for science and grade 6 to 10 for maths is being donated for all the schools of Karnataka state to access for free. It includes student content as well as teacher content. To access the teacher content, you may have to come to the platform, log in. It's a pretty simple process. I'll be talking about it towards the end of the session. And what we also intend to provide, again free of cost as part of this program, is the support that you'll need to implement these activities inside the classroom. Without taking more time, let's have a look at some of the activities so that you get some idea about what we are talking about. So let me make myself more visible so that we can. Okay. Some of these tools sometimes I have a little challenge in speaking Kannada. I'm still learning it, but my colleagues are there who are continuously monitoring the chat. So if you have any questions, let language not come in the way of our communication. So if there is anything that you want to know, you want to be translated, then please put it on the chat window. Let us start with something very simple. I will probably take a couple of papers here, and so as I said, our work is primarily about using simple materials. We got hooked to this when we started looking at this gentleman's work. His name is Arvind Gupta. Many of you would have heard about him. And the inspiration that we draw from him, we have extended the same to the other activities that we have designed to fill the curriculum gap. So I'll start with something very simple. Again, this happens to be one of the Arvind Gupta activities. I have an A4 sheet and I can roll it in two ways. So one is, so as you can see, it has one longer side which is approximately 30 centimeter. The shorter side is approximately 21 centimeters. And I can roll it to make a cylinder. So I can roll it in two ways. One is along the longer side and other is along the shorter side. And by doing that, I will get two cylinders. So here, and I've deliberately maintained paper only so that it's easier to work with, and you realize that you don't need much. So if you have to do this in the classroom, all you need to do is join here at the center. So I have one which is a shorter cylinder and another one which is a longer cylinder. Yeah. And my question is, do you think the space they both occupy, is it same or different? And so as to answer that question, let us have a quick input from all of you, and for that I want you to respond to this poll question. So for you to answer to the poll question, I want you to go to this channel. I'm typing it on the chat window. It's called itempool.com/SM, which stands for secondary maths SMKAR SM Karnataka /live. So I've pasted the link to the to the poll site, and let me launch the poll, and I'll also share the responses. So okay, so let us look at I have not got any responses yet. So if you have any questions, then please type on the YouTube URL. I'll put the chat again. So I guess the poll went at the bottom. So just go to itempool.com/smkar/live. Yeah. And it would be good if we interact, because that gives me a confidence that you all are also thinking, and the points we want to communicate, they are reaching across. So just in case there is a challenge in understanding the question, let me take you through the question. So I've made two cylinders by rolling the A4 sheet in two different ways. One cylinder is shorter than the other. What do you think is the radius of the base of the taller cylinder? So we have one cylinder which is tall than the other. And what I'm asking is, what do you think is the radius of the base of this tall cylinder? And you can assume that this is 30 centimeter by 21 centimeter. So my colleague has again pasted the link. I still don't see any responses. This is where you have to go, itempool.com/smkar/live. So you have to select one of them and then click on submit. Okay. And I know this is taking a little while, but I still want to wait patiently, because it's important that we are interacting. I see that on the chat window many of you have put other messages, but I would like to see. Okay, so Jagdisha sir, I see that you have responded on chat as the answer as 15. Please respond on chat. Very nice. This is very, very encouraging. Thank you so much, all teachers. So I see that you all have started responding. Let's wait for another 30 seconds maybe, and then we will have a look. And we will find the answer in both ways. Okay, we'll do it practically, and we will also look at it mathematically, because especially when it comes to maths, you can't just look at the practical aspect. We also want our students to be able to generalize. So I've still got only 3 responses. Very nice. That's the 4th one. This is very, very encouraging. Please continue to respond on chat. Okay, I guess we will end the poll here and move. Okay, so what is the correct answer? Let us stop this and come back. And I want you to think about it. So how would you go about doing this calculation, right? So you have 30 centimeter. Now, if the base of the taller cylinder, if you think the radius is 15 centimeter, the question I have is, what do you think is the radius of the shorter cylinder, and which one will have higher volume? And so as to do this, many of you would have seen this experiment. All I'm going to do is, since this has a bigger diameter, the shorter cylinder has a bigger diameter, I'll put the taller cylinder inside and I'll pour this with some sand, and at the end we will take this out and see if this gets filled to the top. Does it overflow? And I've deliberately kept this flap openable so when you do this with your students, you can also use a cardboard instead of paper to make it more firm. It's not necessary to make the base, but that sometimes gives that stability. Now, let me see if I can clearly demonstrate this to you. So what is my setup? I'll change the angle of my camera so that you can see it clearly. So what I have here is one container so that the soil which spills over, that does not make it dirty, and so that I can pour easily, I have cut one of the 2-liter bottles which can be used as a funnel. Okay, so let me again change the camera, and so I have some soil in this. It's not necessary to use sand. Sometimes regular soil, one problem is that if it is wet, then it may not go through easily. But what we should do is pour it gradually and keep shaking the funnel so that it doesn't get stuck. So just be little patient. I'm doing it carefully because I don't want my laptop, etc. to get messy. And these are, by the way, large cylinders, and that's the reason the volume that they have is much higher. So I'll have to probably pour a lot of sand. As you can see, I'm shaking the funnel regularly so that it's almost filled. I'll probably change the angle of the camera to show this to you. And if you do this theoretically, I'm pretty sure that given that you all are high school teachers, qualified enough to figure this out, but for the students, it is extremely valuable. So as you can see, so now so it is filled up to the brim, and what I am going to do is lift this cylinder gradually. I'll again put the laptop back because I'll need 2 hands. It's a lot of soil. So I'll gradually lift this and allow the sand to go to the bottom. So I've taken this out. Now let us check the level of sand in the fatter cylinder. So as you can see, I'm able to put my hand up to here inside. So there is this much gap inside. So clearly the fatter cylinder, this cylinder has a larger volume compared to the taller cylinder. Now let's apply the theory and verify that this is the case. Now what do I mean by applying the theory? Let me just put that aside so that I don't create further mess. So if you look at it, this is 30 centimeter. So as to get the radius of the fatter and shorter cylinder, you need to see what is the circumference. So what do you think is the circumference? And I know the length of the longer side of the A4 paper. So what do you think is the circumference of the base of this cylinder? You can type on the chat window and let me see your responses. I see that some of you said 15 centimeters, some of you also said volume is same, but as you saw, volume is not same. The fatter cylinder has higher volume. Yes, Manjunath has said, thank you Manjunath, exactly. So the circumference of the base is 30 centimeter. So now how will you get the value of the radius? 2 pi r equals to 30 centimeter. Now if you solve, you'll get r equals to 30 divided by 2 pi. And that means if I approximate it, so if I say that approximately this is 3.14, so I would divide 30 by around 6.5, so it would be closer to 4.7, 4.8 centimeter. That will be the radius of the base of the shorter cylinder. Now the taller cylinder, if I want to do the same, I'll have to consider the circumference as 21 centimeter, and hence I'll get 21 divided by 2 pi, which is 10.5 divided by pi, which means it will be, radius will be close to 3.5. Now the interesting thing is, if you apply the formula of pi r square h to get the volume, height is different. So one has 2/3 the height of the other, but radius, which is double, so it's getting squared, and hence it gets multiplied 4 times. And that's the reason pi r square h, the one which has bigger radius, that will have bigger volume, of course to certain extent. So if r square is equal to the difference in the height, then you'll start getting the same volume. And so as to apply this back, right, because it's when we apply these things in daily life, that's when the fun comes, right? So let me launch the next question. So go back to the poll, and this time we will use a real life scenario. What is the scenario? If you had to purchase gulab jamun. So if you had to purchase gulab jamun and you have 2 jamuns of 2 different sizes. One jamun is exactly double the size of the smaller jamun. Now in the beam balance, a balance which we used to have in old days, one side if I put 1 big jamun and the other side I put 4 small jamuns, then which side will the balance tilt? Will it tilt towards the big jamun side, the small jamun side, or will it remain same? And of course I am asking about the mass, but what is important here is we are looking at the volume, and you can assume that the density of both the jamuns is same, and hence if the volume, the one which has higher volume will also have higher mass. Let me see if there are responses on chat. When we take h equal to 30 centimeter, then volume is 1273.3. Vasant Chetna, that's so nice that you have done this calculation as well. These many cubic centimeter. And can you imagine how many liters would that be? And when we take h equal to 21, then volume is 1503. So are we saying, so something has gone wrong in your calculation? Because if you look at it, it appears that uh, with 30 centimeter, the volume would be close to 1,27,000 liters, whereas with 21 centimeter, it will only be 1,500 liters, which is not true. We just saw that it's only little higher. So thanks for doing the calculations, by the way, because that's very, very useful. Savita ma'am has put this in Kannada. I don't know if it is a response. Okay, so I see that some of you have responded. Okay, let me go back to the poll question. So two people have responded, and we'll probably wait for another 30 seconds and then stop the poll. Because it would also be good for us to make one of the activities which we have planned today. So let's do that. It's so nice to see that you all have uh, shown up in large numbers. It would be good to, uh, sorry, it would be good to also experience what our children experience, that is making one of the activities. Okay, so 4 of you have said it will tilt towards the big jamun side, and one has said towards the small jamun pan. And the correct answer is big jamun. And the reason is very, very simple. I will, so before we go to the next one, reason is very simple. So in one case, the big jamun, which is double the size. So if you calculate the volume, it is 4 by 3 pi r cube. The other one, which is half the radius, it will be the same radius but 4 by 3 pi r cube divided by 8. So if you put 8 jamuns in the other pan, then it will be balanced. 8 small jamuns is equal to 1 big jamun. And this difference in the volume is something that we sometimes cannot visualize. So if you think about it, I've come across so many students who get programmed on one side that we must convert everything to SI unit. According to the SI unit, what do you think should be the unit of volume? And I want you to respond to this on the chat window. What's also interesting is SI unit should be meter cube, but we don't just, so in daily life we use liters. So imagine going to the milkman and saying, give me 0.5 meter cube of milk, right? So daily life we use something else. There we say liters. Here we use meter cube. And as we just saw, if you practically do anything, most of it comes in centimeter cube. And the reason is very simple. 1 meter cube is a huge size. It's actually the 1,000-liter tank that most of us have. Most of the independent houses, they have this Kaveri tank or this Syntax tank. They are 500 or 1,000-liter tanks. And it's hard to imagine that 1 meter cube is actually 100 centimeter by 100 by 100, and hence it is 10 raised to 6 centimeter cube, which is nothing but 1,000 liters. So it's important that we give this perception about volume to our students. Now let's go to the next activity. This time I'll probably do something else. Since we are dealing with numbers, let us have a look at some of these numbers which sometimes trouble us, right? We say there are rational numbers and there are irrational numbers. Now, why are these irrational numbers called irrational? Again, we don't require a lot of special material. I'm just taking another A4 paper and I'm folding it in the middle along the longer side as well as along the shorter side. And what am I going to do? So the crease that I have got here, I'm going to draw one line on both of these. So just give me a minute so that I can do this drawing in parallel. And this is one activity which, if you are interested, you can also do with me. You will require a ruler and maybe a pencil. Okay, you will require a protractor a compass, a pen if you want, otherwise you can also deal with pencil, and a regular 15 centimeter ruler. So what am I doing next? The line along which we have made the crease, I'm going to draw the axis. Okay, so all I want you to do is, I've drawn one axis here and one here, so that will give me one origin. I could have used a graph paper, but sometimes the graph paper has too many details, because of which sorry, what happened, it has lots of boxes, and that is confusing for children sometimes. Okay, so I have one line like this, one line like this. What am I going to do next? From this point, I'm going to make one arc towards the x-axis. One arc, how long? I would say take any length. I'm not measuring. I have fixed the pencil, and any length, what I'll do is I'll place the compass, and as you can see, I've made one arc here. Okay, and that becomes my first point, and from there I'm going to draw one perpendicular. So I'm placing the protractor here, and I'll draw one perpendicular line in the upward direction. So this may appear a little lengthy, but as you start doing it, and these are some of the activities which all children should do, and also all teachers should do themselves, because it's not sufficient that we watch or show the video. It's a different fun when we do it ourselves. So I've drawn one perpendicular, and now what I'll do is I'll place the compass again here, and I've cut one more arc. Now if I join this point to the origin, I'll get one right angled triangle. And my question to you is, in this right angled triangle, what is the angle which the hypotenuse is making with the base? Pretty simple question if you apply some of the basics. I'll show the triangle again. So as you can see, I've drawn one arc here and one more arc of the same length, and joined these 2 points, this point and the origin. What do you think is this angle? And you can respond on chat. And in the meantime, so it's important that this distance does not change, because what we will do after this, we are going to use the same length. So it's important that your compass remains undisturbed. So as we do this, let me see the responses from some of you on the chat. Manjunath, Sampurn, that's such a nice name, Sampurn Jain. 45 degrees, very nice. We all are converging, we all are saying 45 degrees. It will exactly be 45 degrees. Okay, but the fun starts now. So what am I going to do next? This time, so as you can see, so this is how we had done. So we made one perpendicular from here, considering this the x-axis as the base. This time I'm going to consider the hypotenuse as the base, and I'll draw one more perpendicular, and the length of this perpendicular line will be same as this. That is, I'll draw the arc using the same compass. And my question is, this hypotenuse that I'll get, what will be the angle that this hypotenuse will make with its own base? Okay, and for this I'm launching the poll question parallel to actually doing this. And as I said, it would be great fun if you also do this along with me, because what you'll get at the end would be something very interesting. Very nice. I can see one response already in, and in case you have not been able to visualize it, I will show it again. This is what I'm doing. So I've taken 90 degree with the hypotenuse as the base and here. So now I'm going to cut one arc which is same length as before. And I'll join these 2 points. So this is also a right angle triangle, and my question to you is, what will be the angle of this hypotenuse? Will it be 45 degrees, less than 45 degrees, more, or you can't say, it depends on the length, because I have not given you the dimension. I didn't tell you how long this was. Okay, so let me show you. So we are talking about comparing this angle with this angle. Let me see the responses and end the poll. I'll also show. Okay, 3 people have responded and looks like all 3 have given the same answer. We'll finish here and let me reveal. So all 3 of you have said this will also be 45 degrees, but it will not be 45 degrees. let's understand this, right? How this has happened. It will always be less than 45 degrees. And let me show you, let me explain this. And I'll show one more picture where this will become even more apparent. The length of this, if this is x, this is also x, and that's the reason many of you immediately said the angle made by hypotenuse will be 45 degrees. That means the length of the hypotenuse is square root of 2x, which is around 1.4142, so slightly longer than x. So now if my base is bigger than the perpendicular, so imagine a right angle triangle. If this starts becoming longer and longer, then so if this is my right angle triangle, if my base starts becoming longer, my hypotenuse will start going away, and because of that, this angle will, what will happen to this angle? It will keep becoming smaller and smaller. And you can of course apply trigonometry and cos theta, sin theta, etc., and also arrive at the same answer. But it's important that you try to visualize it just as a physical object, right? Then you can very clearly see that as the base keeps becoming longer, your hypotenuse will start making smaller angle. Now let me show you the complete picture of when this is extended further. So this is the same thing. The length was different, but as you can see, there is a very interesting diagram, very interesting spiral which comes out. Now I am calling it a spiral, and it is a diverging spiral because the length of the hypotenuse continues to increase, but the angle keeps becoming smaller and smaller. So it is 45 here, it will become something else, and this is reducing. So as you go further away and away, this angle keeps becoming smaller and smaller while this keeps becoming longer. And if you had to make this further bigger, then you'll get some very interesting shape. Do you remember seeing this anywhere in your daily life, this kind of shape? Let me see the responses on chat. Yeah, as Samarth Gaming, I don't know, the name showing here is Samarth Gaming. As it says, it will be smaller. Theodorus cycle, okay, snail, yes, right? And if you look around, in fact, nature has so many such patterns, right? And as Mohanji is saying, shell. So, and that clearly tells us that in real life, there are many such interesting patterns based on pure mathematics. What's also very interesting is, so if this length, the first length, if I consider this as 1 unit, then my first hypotenuse of the first right angle triangle is square root of 2. The next one will have the base as root 2, and again the height will be 1. So root 2 square plus 1, so the hypotenuse will be root 3. The third right angle triangle will have a hypotenuse which is root 4, root 5, root 6, and it will continue to be exactly this, root 2, root 3, root 4 will continue to increase. See if you can also arrive at a pattern about the angle in a similar fashion. Okay, let me now show a few resources online so that you also get an idea about the other resources, and then we'll quickly make one of the activities. And for this activity, if you keep some paper, ruler, pen, just this much ready with you, it will be easier to work on the activity. Okay, let me share my screen and show you some of the resources on maths. In general, I want to ask this one question. So right angle triangles is something that many of us see around. There's entire Pythagoras theorem, as well as the trigonometry field is based on right angle triangles. What do you think? Why are right angle triangles so much important? We get to see so many triangles. What's so special about right angle? Why do we go deeper and study only this category of triangles? I'm not sure what is this response to for the 30 degree or less than 45 degree. Okay, so let me share the screen and show you another activity. So on maths, we have started doing work very recently, just less than a year. Our expertise has been on science, and hence some of the videos are still under production. What I'm showing you is the guide, but I'll also show you one video to give you an idea about what's the nature of videos being created. So these guides, these are step-by-step instructions along with pictures. So what you do is, first you take any foam base. Instead it could have been another cardboard. You stick that after making a small hole, and there is a ruler template printed on paper which is stuck on a card sheet. The reason this is required is we want exactly 15 centimeter long arm length. So you create 4 such arm lengths by sticking this on cardboard, the 15 centimeter ruler printout, and now you start joining them using any joint. In this case we are using nut and bolt, but it could have been any broomstick as well. So you join them at the point where both the 0 centimeter of the two sticks are merging, and at the other end, that's the one which you fix here. And as you make these connections, so you also make one joint here in the center around 7.5 centimeter, and once you have these two X in place, you join them and you have something very interesting. So as you can see, there are two X which have been joined together, and let me increase the view so that you can see it clearly. So now there is one arm where we have fixed a pencil. The second arm, the longer one, there a sketch pen has been fixed. Now you draw one circle here and you get another circle which is bigger, and the size of this circle will be exactly double of this circle. My question to you is, can you think what should I do if I want to make a 3 times bigger circle? By looking at the design of this, what is known as pantograph. So you can search on pantograph, plenty of YouTube videos are also there. So this pantograph, if I want to make a 3 times bigger shape, then what should I do? And by the way, what we are seeing here is Yeah, Mallikarjunappa is saying staircase is also a spiral shape. So the spiral diagram that we saw, it also reminds us of that. Sorry. So the pantograph, if you want to make a 3 times bigger shape, what would you do? And I want to draw your attention to the fact that our curriculum covers similar triangles more often, but it's important that the concept of similarity goes into the head. So in all these cases where, let's say, a printer makes a two times bigger uh, printout, where the image gets enlarged, that's essentially creating another similar shape. So similarity is not just applicable to triangles. We in curriculum we solve more problems related to triangles, but it can apply to any shape. And what we are seeing through the pantograph is similarity being applied in any random shape and nothing highly technical, just 4 sticks. Okay, I don't think I've got any response on what should be done to make a 3 times bigger shape. We have 2 sticks, 2x's. You make 3x and attach to the last one, then you'll get a 3 times bigger shape. It's as simple as that. Okay, let me show one more and then we will go into the making. So what I have with me is a simple binding wire. So I'm showing it in the darker background so that you can see. So it's a thin wire which is very non-elastic, and hence I can give it the shape that I want. So what's the shape I'm going to give it? So I'll bend it in a loop at one end, then I'll bend it in a loop at other place. So I have 2 loops, and I'll do that at the third end as well. And this way what I have created is a 3-sided loop. What am I going to use it for? So these days single-use plastic straws are getting banned, though plastic is seen all around in all the wrappers. So maybe you don't get them easily, but hopefully if these big companies selling soft drinks or juices, if they can manage, then we'll continue to get fruity straws. So you take a fruity straw and one end, so you see this loop, I'm going to push that into the fruity straw at one end, and the other end I'm going to insert a second fruity straw. Some of you may have seen these matchstick models which Arvind Gupta makes. So you can also use that if you use the cycle valve tube and matchsticks or skewers or broomstick. Those can also be used to make these models. So as you can see, after inserting, now I have these 2 straws joined and I can make these structural models. Here I have made one pentagon with a stick, and all of them have these 3-way joints, and I can continue to attach and make larger structures. So one of the challenges which people often have is to visualize a sphere. So you can draw a circle using a compass, but how do you make a sphere? And this is one thing which this gentleman called Buckminster Fuller, and it's called Buckminster Fuller's model. So let me show this model which can be made using the same setup. Okay, so as you can see here, this is a completed ball. So it has one pentagon, and around that there are multiple hexagons. And what's being done is you take a bunch of these wires. There will be a total of 12 pentagons which a typical football kind of ball will have. So you make these joints which are made from wire and attach these straws. So this kind of activity would be a perfect one to do in a group. because otherwise it will take a long time. But let's say a group of 5 children, if they are sitting together, trust me, it looks pretty simple, but it's not easy to visualize the entire structure. So as they start putting it together, you need to be mindful of this fact that you have at the top you have one pentagon, around that you have 5 hexagons, and after that you again have 5 pentagons. And in this manner, as you start attaching them together, a beautiful ball comes out at the end. And when we have done this activity with children, they find it extremely exciting. Let me show what you can do with it. So plenty of things can be done after that. Let's say something as simple as this, that I use it for, let's say, measuring the volume of the ball, which can be done by something like you, let's say, insert a balloon, blow it, and then dip it in a bucket and see what you get. You can also estimate it by measuring the length of the sides. Okay. Now let us switch to working on one of the activities. So I hope you all are ready with an A4 paper. As you can see, majority of the maths activities, they can be done using just a simple paper. Let me take so first thing we are going to do with this A4 paper is, it's rectangular in shape. We are going to convert it to 2 squares. Okay, what do I mean by 2 squares? We are going to fold this into half, and as I do that, I get an A5 sheet. And if I fold this here at around 45 degree and remove this strip, then I'll get one rectangle which has 2 squares on the 2 sides. And just so that you can see it very clearly, let me play the video for this. Just give me a minute. I'll pull out the video for making, and I'll play the full video so that you get to see the end result as well. Okay, let me share. Okay, I hope you are able to see the video. I'll increase the speed so that, because we are going to make it together. So as I said, the first step we are taking is folding it into half. I'll change the speed back to normal. I think it may be too fast if you are doing with me. So here we have one rectangle with 2 squares. We are folding it again to the middle line, and then this strip we are going to convert it into 8 equal sized rectangles. Now this is the tricky one. Let me go back to this step. So as to get this middle line, see what we are doing. We are folding one strip at the end, and then this will give us the middle line for the. So we have divided it into 8 equal rectangles. It's important for this activity that your crease is very neat, which is why it's being pressed again. So the way some of you may have seen this horoscope being made, so the way we make a rhombus at the center, a diamond, and the diagonals, the same shape we have to make here. So once you are ready with the horoscope on both the sides, along each of these lines you have to fold the paper, and it's best if this is done by placing a ruler. After that, one out of the 8 rectangles, we remove it, and along these triangles we fold it, and we will get 3 hexagons. And what's interesting is, once you do that, each of these hexagons from the top, you will just be able to press them down, this parallelogram. And what you have from a plain 2D paper, 2-dimensional paper, is this amazing 3-dimensional shape. No scissor, no glue, no tape, but this is one shape which continues to rotate, and that's the beauty of this. And of course there are various things which people do. They stick a food chain, or let's say the nitrogen cycle, carbon cycle, etc. We are going to look at the different shapes that it makes and explore similarity and triangles and similar shapes, etc. Okay, I hope you are ready with the paper, and we will start now. So what I have done here, will do the first step. I have folded this into half, and we are going to fold it along like this. If you are doing the activity with me, please take a few pictures, especially at the end. You will need them when you ask for the certificate for this training, for this orientation program. The process which we have been instructed by DSERT for issuing the certificate, that involves getting a verification, and also you'll have to attempt one quiz. So I have done till this step, so that I have one square with one rectangle with 2 squares. Now I'm going to label these 4 sides. Why will we do that? We'll come to that because there is a very interesting question hidden here. So let me name them as A, B, C, and D. Okay. So I have marked the 4 vertices as A, B, C, and D. What will we do next? I'll play the video and also repeat the same step at my end. So we are done till this step. Now we will do this. So 3 folds. Let's do that and come back. So I have folded it in the middle and I'll again fold it from the two sides. Okay, let's execute the next steps, which is about dividing this into 8 equal strips. And if you can also do if you draw the lines, then you can very clearly see the markings. Okay, before we go to that step, let's pause here and let me show you what I have made. I've been playing around with this long. Okay, so I had A, B, C, D here, and these are folded. Now the question I have is, as we said, this time let's look at the similarity of rectangles instead of similar triangles. As you can see, now I have further labeled these rectangles. So I have E, F, G and H. So E, F, G, H. Then I have one more rectangle here, which is I, F, G and J. So I, F, G and J. And the last one, this one, which is E. Let's look at this side because that's what I have labeled. F. So K, F, G and L. So I have 3 rectangles. Which of these 3 rectangles do you think is similar to the original rectangle? And of course, if you have the ruler with you, you can also do the measurement and check. I'll again launch the poll question for whatever worth it is, because I'm not sure how many of you are actually responding. If you go to the same link, you can. So the question is the ABCD, which was the original rectangle that we saw, which of these is it parallel to? And EFGH is the folded, the large rectangle. FGLK, that is the small one, a single strip out of the 8. EIJH, that is the half of this rectangle. And fourth option is none of them are similar. And we'll probably wait for another just 20 seconds to see, because I'm not getting the confidence if all of you are looking at these poll questions. Even if you are not, please at least just do the activity. It's a lot of fun to get it working at the end. Okay, that's very nice. We have 2 responses, please. We have close to 200 people watching the video right now. Okay, let me finish and reveal the results. So 2 people, both of them said it's similar to EFGH, but the correct answer is FGLK. So let me show you how that's happening. So ABCD was this original one. This side and this side, if you look at the ratio of that, this is 2 times this length. If I do this now, which both of you, the two people who responded, you have said that this rectangle is similar to the previous one. But if you look at the ratio, this continues to be the same length, which is now 4 times this length. So this can't be similar to the previous one. And what about this? Because this, we will say that this divided by this is 2 times. So don't you think that is the correct answer? But if you notice, so this has become half, and this has also become half, right? So this is also uh, similar. Now what's also interesting is this small strip. This, if you rotate it, then this is also similar to the original ABCD, and it just requires little uh, attention to. So if you start putting, let's say, numbers or doing actual measurements, you'll realize that both of these are similar. Similarly, once you start drawing the triangles, I'll not launch this question or wait for your response, more in the interest of time, and I'm not sure how many of you are getting it. If you look at some of these triangles, right? So there is one which has been shaded here, that if you compare with this triangle, both are right angled triangles. What do you think? Are they similar to each other? And this is exactly what we want our students to do. Sometimes we glorify experiential learning, but experience alone, if that was sufficient, then we all would have been equally learned. But after the experience happens, it's important that they observe, and we draw their attention to some of these details. So in the observation sheets that we provide for this activity, we ask the students to actually make the measurements of the angles of the sides and check if they are proportional. So we'll continue with the making of the activity. So if you draw these lines and start folding along the lines. So I'll play the video again and we will make in parallel. I hope you all are also making along with, and please continue to share. So as you can see, if you use a larger ruler, a 30 centimeter ruler, then it will work best. So we'll stop at this, we'll pause at this step and go back. So I'm also making parallel to this so that you can see the so as you can see, it will become something like this if you fold along each of these lines. After some time, the three-dimensional shape starts showing up, and you'll also see these beautiful triangles on the back side of these papers. I've been taking this session in English. I'm not sure if that is also coming in the way. So what we will do is we will have one more session next week, which we'll get the permission from DSERT, and we'll try to have one of our Kannada facilitators take that, so that in case language is a barrier, then we are able to. Okay, so I have made all the folds. So if you'll count, there is a total of so each of the two rhombi, so that is, so each of these, so 1 2 3 4, so 4 plus 4 8, and the diagonals, So that makes it around 12 lines have to be folded. So what we'll do next is one of these 8 strips. So as you can see, there are 8 rectangles. One of these 8 rectangles, we are going to cut it. And let me play the video again parallel to this. So we'll go back to this step. Yeah. So as you can see, she has cut the extra rectangle and inserted inside. So now I have 7 strips, and after I fold, so note that this one strip, it will go inside, so that will make it a total of 6. So out of the 8, since 2 rectangles are now overlapping, we will have only 6 rectangles. So I've inserted it inside, and we are ready with the 3 hexagons. So of course, if you look at it like this, then it is only 6 rectangles, but if you look at it vertically, then you'll be able to spot the 3 hexagons. So this is a triangle. Now let's play the video again. So there is one isosceles triangle on the top, which has to be folded, and you do that on all the 3 sides. And as I said earlier, it's important here that we crease it well. So I'll pause the video here again before we go to the next step. So what I am doing is and one, let me do it live. So as you can see, this is the triangle. So if, because we had made the creases in the beginning, it will very naturally bend there, and I'm creasing it well so that, so as you can see, now I'm ready with the front. You can see 1 hexagon, second and third. So you have the 3 hexagons ready, and again you can apply some pressure on the crease to ensure that it is neat. Now let's look at the entire step and complete the flexagon. It is called a flexagon because it's a 3-dimensional polygon which flexes and continues to flex. It's so flexible that it keeps rotating. Okay, so let me complete this. So I'll also bend it from all the sides, and we are ready to play with it. So as I flex it, so initially the paper, till the creases fall in place, it will be some effort, but once it starts rotating, then it's amazing. It would be so interesting to check. So what do you think these, so if you pay attention here, so you have one, so let me draw these creases so that you can see the triangles. So how many triangles do you see here? on one face of the flexagon. So you have 6 of them. So 1, 2, 3, 4, 5, 6. What do you think? Are these 6 triangles congruent to each other, similar to each other? Are these equilateral triangles, isosceles, or it depends on the way we make? And let me show you one bigger model of the same thing. Just one second. So by using cardboard, I had made the same one, a much bigger model, where essentially these 3D shapes, they have been, which are all tetrahedra, tetrahedron which has 4 triangles, they have been joined together using the tape, and with that I have made this bigger flexagon and quite sturdy as well. Okay, with this I've come to an end to the discussion about the activities. Let's have a look at the program and how can we work together. So just give me a minute, I'll share the presentation again. Okay, this is not what I want. I want the slideshow. Okay. Okay. So we just had a quick demonstration. So what all resources will be made available to you? So as I just said, experience is only one part of the learning. So when we started working with a variety of children and teachers, we realized that after the experience, it's important that we make the students observe specific things, because on our own it's likely that we miss out on certain observations. For example, right now, if I ask you a question, what is the color of my t-shirt? It may draw your attention. Some of you may have observed that it's blue in color, but some of you may have missed it. If I ask you a question based on the shadows that you are getting on the wall, can you infer how many light sources I have in this room and what is the direction in which light is coming from? So of course you'll be able to answer that, and it would be interesting to think about it, but I'm making you think about it by asking this question, and that's exactly what reflective observation does. And after they have observed and developed an intuition about what's happening, it's important that we host a discussion with the teachers and also generalize and do a conceptualization, which is what we were also doing today. That initially when we looked at the volume of the 2 cylinders, we first experienced and we saw, okay, one has a larger volume, but we had few questions around it. We were reflecting back, did some calculations, and at the end we did complete the cycle by talking about the fact that when r square happens or r cube happens, if you have a smaller radius, then the reduction volume or area is significant. Similar thing has to happen. The conceptualization is important stage of experiential learning. And after that, as they actively play around with it, that's when the learning gets completed. So what are the resources which are available for each of these stages? So for the experience itself, there are these uh, instruction guides, as some of you saw one example that I showed. The flexagon video that we watched, 2 to 4 minute instruction videos. For reflective observation, there are these observation worksheets where these specific questions are asked. As children fill these worksheets, that helps them develop some intuition before the discussion happens. Now for the discussions with the teachers, all of you will be getting these 15 to 20-minute videos which connect the activity to the concept that they have been mapped to from the curriculum. as well as PowerPoint presentations. And at the end, a quick recap quiz, around 6 to 8 questions, thinking about what all we learned from this activity. When you implement these activities in the classroom, based on our experience, we have realized that what works well is a block period. So if you allocate one block period, let's say once a month or once in 2 weeks, then it's effective. And that block period of 80 minutes is typically split into these 4 stages. If you are not able to get a block period, maybe you can split it into 2 periods. So as you saw, each activity involves some making, because we feel that when children use their hands and from raw material, so it was a plain A4 paper, but from that we made a 3D model which flexes, right? So when they go through that process, one, of course, their hand skills get developed, but they develop a sense of empowerment that, oh, if I get an A4 paper, I can make this on my own. So all the children that we have seen, they get a small, let's say, bill from somewhere, and they are sitting idle in the while traveling, they start making flexagon. That's a very common observation that we have. After that, the observations takes 10 to 15 minutes. Concept connection with you, that's 15 to 20 minutes, and the recap takes 5 to 10 minutes. What I want to highlight is all the resources at all the 4 stages. All of them are going to be shared with you as part of this program, and again, absolutely free of cost. There are no hidden interests here. In terms of learning outcomes, we have noticed that these tactile activities, they definitely help in getting better clarity in terms of concepts. But the key thing is, because these are simple material, it's very easy to change things, and hence children explore spontaneously. So the flexagon itself, we took a rectangle which was made of 2 squares. What if we take a smaller rectangle? So instead of 2 squares, it is 2 equal rectangles on the 2 sides. Will we be able to make a flexagon? And in that case, will the shape of the final flexagon be same or different? So invariably, children end up doing these kind of explorations on their own, because it's only about getting another paper and trying it out. And hence, because of that, the critical thinking also gets developed. Okay, sorry about that. Let's go back to we'll probably use another presentation to cover the next of the aspects. Just 1 minute till we do that. Okay. Let me open the next presentation, because we also wanted to now share what do you do next, right? We have talked about this, you all have attended the training. What will happen next? So the next steps are pretty simple. All you need to do is access the resources by logging into the platform. And as you implement these programs in your classroom, if you need support, we are building a community of teachers where we want to connect all the school teachers from the state, Karnataka state, into one community. Note that the groups will be made based on the grades that you are teaching. So if you are a high school teacher, then you will be put in one particular group. Also based on the district. So we have identified 19 total districts. So there will be a total of 114 groups, but there will be 19 groups related to the secondary maths teachers for the 19 different districts. For the material, so especially for maths, almost all the 7 activities, they don't require any special material. But some of them, like let's say I showed the straw or wire, or let's say making the pantograph, maybe some extra material will be required. If you are not able to arrange, what we plan to do, the vision is that through the teacher community, we will track, we will recognize and reward the teachers who are more committed. So if you join the community and share how you have implemented the 3 activities in the classroom, for the remaining 4 for which you require special material, we will arrange the kits through CSR funds. But as I said, we always have limited funds, so it will depend on the commitment that you show. What is this digital platform that we are talking about? On the platform, you'll have these separate classrooms for each grade, and inside the classroom, you'll have the resources for each activity. So this is how it is organized. What you are seeing right now is one 7th classroom's snapshot, 7th grade's classroom. There are resources as well as resources for teachers, which, as I said, includes the PowerPoint presentations and videos. So how do you get access? Obviously, there is no cost involved. We'll be sharing a form with you immediately after this presentation. In fact, my colleague Shivani, she may have already put the link to the form in the YouTube chat window. So you fill that form. Feedback as well as certificate, both are optional for you. If you don't want to give feedback, you don't want certificate, you can skip it as well. But if you want to stay connected, you share your mobile number on that, because the mobile number is the unique login ID that we are going to use. You will receive the OTP on that mobile number. Within 1 week, we will share it. The teacher community, what all you will be able to get there, I'm giving you some sample ideas what all activity will happen in the teacher community. Every week, 2 days of the week, the ThinkTac facilitators will host live sessions for these 7 activities, one after the other. And the schedule, the calendar, we will be publishing on the teacher community. These live sessions, they'll be after school hours. You can ask your students to attend them. If not, they'll also be on YouTube. So anytime within your classroom hours you want to watch the YouTube video of our facilitator and use that to facilitate, that will also be possible. We will be hosting multiple programs which are driven by the teachers. So let's say we will invite short videos from you where you share how you are making your classrooms interesting. And a selected set of teachers, they'll get the platform to share with this community, the larger community. And that way we learn from each other. As I said, we will be tracking, there will be some kind of point system, and every quarter we plan to recognize the teachers who are more committed. In association with the RRI Trust, we have started this concept called Raman Clubs, which promote innovation, science and maths. And you will have the option to start a Raman Club at your place if you are a part of this community. And this could be your house. You can work with any number of children. And every month we will be talking about the Raman clubs and also talk about the clubs which are already running. Similarly, we will have these frequent events once in a month where we have talks, panel discussions, debates organized on some specific questions. We'll continue to share short quizzes and other engagement ideas for you to engage with your students. Just a sample calendar of what it would look like. So for example, if you enroll in the community, from 19th September onwards, the action will start. So the 1.5 month, this is the type of calendar we have planned. So we plan to have few workshops related to NEP as part of the monthly Saturday expert talks. The activity sessions by the ThinkTac facilitators, they'll start from the 19th September week. We will be sharing the calendar. So how to join the teacher community? It's the same single form as I said, which is the feedback and certification form. So in that you click, just tick that box which says you want to join the community. You'll have to download and install Telegram, because Telegram, we have seen the teachers find it safer. You don't need to share your number, or people cannot find out your mobile number on Telegram, which can happen on WhatsApp. And instructions to join. So if you are interested, based on the category and district, we will be sending you an invitation link, most likely on SMS. This is the feedback form which you need to fill. As I said in the beginning, for you to receive the certificate, you'll have to do two things. Upload an image of the activity which we made today. So in your case, it will be a flexagon that you have to make, and along with your face, take a picture and upload that. That will be on the same form, the carfeedback.thinktac.com. In the same form, you'll also have a 6-question quiz which you'll have to answer, which helps us find out if you actually attended the training or not, because this is all on YouTube Live. So plain attendance will not be sufficient. And in the same form, you can give feedback about this session. It will help us improve it next time. And you can let us know if you are interested in joining the community. If you miss out all the details related to this program with the Karnataka State Board are part of this web page called thinktac.com/pages/carteacher. Okay, that brings us to the end of the presentation. If there are any questions, I can answer them now. No link received. Okay, yeah, I think now it has been pasted. So thinktac.com/pages/carteacher is the link to the website. If you want to fill the feedback, then it is karfeedback.thinktac.com. You are saying the links do not open. 1 minute. Huh? My session is still on and I don't know how to mute. I'm just getting the feedback. Huh? It's yeah, karfeedback.thinktac.com. Okay, I think we can end the video here. I'm just looking at Samarth. Is it available later? Yes, it is available, sir. So once we end the stream, the same YouTube link can be used to watch the video later as well. Let me see. Geeta ma'am, thank you so much for saying that. Okay, I see now Savita and Mallikarjun, you had responded. Even Vasant Chetna, Pavitra, you all had responded to the question about how many triangles you see. So yes, 6 triangles, and as Manjunath has said, these are congruent triangles. Yeah, so Manjunath, that's actually the correct answer. They all are congruent to each other, and only then, because it's entirely symmetrical if you pay attention. What would be interesting to also check is, do you think these are equilateral triangles, isosceles or scalene? Okay, it was amazing to see all of you staying as part of the entire session. Thank you very much for giving us this opportunity. We will host this session again, and we'll try to have a Kannada facilitator so that you probably feel more connected. Uh, Please involve other teachers, your colleagues. This is all free of cost. The intent is only to reach out to more and more teachers from the Karnataka state. We will end the stream here. Hopefully, we'll work together and make the lives of many more children better. Thank you.